Hey everyone, welcome back to the Anderson Bros Outdoors. I'm Jake, and today we are going to go over some questions that I've been asked in reference to the Pheonix RTR and the Rock Pirate chassis with the 3D printed stuff. So first things first, I want to talk a little bit about 3D printing. So what I would recommend in reference to 3D printing is you have a setup that works. I have a Creality Ender 3 V2 and also a Creality S1. If you don't have a 3D printer yet, I would highly recommend the Creality S1. Actually, I would recommend the S1 Pro because it's just a touch better than the S1. But the S1 is actually on sale right now in Micro Center for I think $278. I'm not sure. I'd have to. The price will be right here. So, highly recommended printer. They just work out of the box. There's a couple of things that you need to do out of the box to make sure that your print is going to be successful. First thing is the Ender 3 version 2 does not have automatic bed leveling. And I'm not going to cover bed leveling in this video, so there's plenty of videos online that do that already. However, the Ender 3S1, it does do automatic bed leveling. You will need to set the squish rate, and I will show you what that looks like. For the squish rate, you can see here, there's a couple of things that you need to do. First of all, you need to make sure there is no filament coming out of the nozzle, which there's not already checked. And then second of all, if you're using an Ender 3S1 like this printer here, you need to do the bed leveling first. Okay, so once you do that, you can go into the menu and click prepare, and there will be a section called the Z offset. Now, the second step is you take a piece of paper, a thin piece of paper, and you put it between the bed and the printer nozzle. You can hear the dragging sound, right? There is no dragging sound, and as I move the print head down, it stops moving as well, right? So you want to move the print head to where it starts dragging slightly, where you can still move it back and forth. So like right here, I should still be able to slide the paper under it, and it still has a slight drag to it. This is where I leave the squish rate. I would recommend using Micro Center PLA or PETG for your prints. Just know that PLA will be a little stronger, whereas PETG will bend a little more before it breaks. I use PETG for most of my prints because I have a lot of it. I got it on sale at a really good price, so I utilize that for most everything, and it works just fine. Enough about the 3D printing portion of it. Let's talk about the parts. So when you go to 3D print parts, you want to utilize a slicer software. So you'll get a file. That file is in a format like .stl format. You will want to import that to your slicer. You can use Cura, Prusa, Creality has their own slicer. There's many different slicers. I would recommend using the Cura slicer as a beginner because it just works. So you load up your STL in your slicer, and what the slicer does is it creates your layer upon layer upon layer print for the printer to understand and actually create that print. When you load the part in the slicer, that's not really where you want to just, okay, let's export it to G-code and send it off to the printer. You really want to look at the part itself. So there's a couple of different things to look at: your infill percentage, the direction of the part, how it's laying on the bed, and then also the nozzle size and material that you're using. And I'm going to start with the material nozzle size first, and then we'll work our way into the print itself. So personally, I use a 0.6, 0.8, and 1 millimeter nozzles. I don't use anything less than that because I like my prints to go very fast. In the slicer, you need to set the type of filament you're using, whether it's PLA, PETG, TPU, etc. And then you also need to set the nozzle size, whether that's 0.4. And most printers come with a 0.4 millimeter nozzle, so it's likely that that's default for that printer, whether it's 0.4, 0.6, 0.8, or a 1 millimeter nozzle. So just for reference, those are all very big factors to make your print successful because each filament prints at a different temperature, different speed, things of that nature. I'm not going to get into any of that because that's not the reason for this video. If you'd like to learn more, I'm sure there are plenty of tutorials and discussions on YouTube that showcase what and why each filament requires specific settings. All right, so we've talked about the nozzle and the filament. Let's talk about the actual print itself. So as I stated, you can see in the slicer the product on the bed. Now, one thing you need to keep in mind is that the print is going to stack on top of each other in layers like this. So we'll take this pin for an example, right? So if I put the pin on the bed, my hand is the print bed. So if I put my pin on the print bed like this, it's going to print in lines up this way. So it'll print and it'll continuously rise with each layer. Now, if I were to put my pin like this and print it, again, it would do the same thing, except it's going to print it in layers like this. Now, one thing to keep in mind when printing parts is the direction of stress. So if I were to have a lot of stress on this pin going like this, trying to bend it in half, you would want to print it this way, so the layers are horizontal instead of vertical. What that's going to do is, if you have vertical layers, your pin is actually going to break very easily at one of those layers. Versus if you're printing it horizontally, it's a lot harder to break because you have a full string from end to end. Now, if I were going to put a lot of stress on it this way, I was going to use it as a pillar, I would want to print it like this, because those layers are going to be like this, and then I'm smashing the layers together, increasing the strength. Whereas if I printed it this way, the layers are vertical at this point, and it actually makes it weaker because the layers will bow out under pressure. So just some things to keep in mind. If you have unsuccessful 3D printed parts, it's not necessarily because the part is designed bad or your filament sucks. It's that it needs to be printed in such a way that you are using the part to its advantage from being printed. Now, we could go down the road of filament versus resin printing, but we're not going to do that. Again, watch another video for that. I have not actually used resin printing because I don't have the space for it at this time. Not going to discuss it. With that being said, I'm going to show you what my bed looks like when I'm printing the Vanquish RTR parts out and how I print these parts. We will pull that up on our screen, and I'm going to share my screen right now. All right, so you can see my screen here. We have, this is Prusa Slicer open, and then I have my parts imported. So basically, to import your parts, you go to the plus sign here and you add the part. You can see that I'm missing one, so let me add that real quick. So I'm missing the bumper. I've added the bumper, and you can see that now we have all of the parts for the build here. I'm going to rotate the bumper because it is not in a way that I want it. And one thing for reference, when you're using this and rotating it, if you see it has the small and then the box, if you go to these big long lines in the middle, it'll actually make it much easier for you to rotate in a exact degree versus out here where you have the potential of not getting it exact. So here it's 90, here it could be 93.75, whatever. So just keep that in mind, and then we're going to move some of these things over to make room on the bed for this bumper. So now you can see that I've got this one part printed this way and this part printed this way. So normally I would have both of these parts printed vertically like this. However, since this part is got holes in it, I don't really want to do supports, so I'm going to print it horizontally. Another thing to note here is that if you look at the actual mounts for the back of the bed, I have them printed where the body mounts, where it goes into the hole. I have them printed down because I want them horizontally printed. I could flip this over, right, if I changed it 90 degrees and print it like this. However, I do not want the lines to be horizontally. I want them to be the other way, because if these are printed horizontally, this is going to be brittle and weak. So I'm only saying that because I did not catch that the first time I printed it, and I broke the tabs installing it. Just kind of an FYI there. And then, as indicated in the last video, I did update and add an entire servo mount here for the Rock Pirate chassis, and then also the bumper support. So I haven't actually tested this servo mount out yet. I'm about to print it out and test it out. You saw how I was able to utilize Prusa Slicer to import the parts, manipulate them how I wanted them, and then all you have to do is hit Slice Now and export the G-code. Pop the SD card into your computer, export it to the SD card, and then put it back into the printer. It's really not that hard. The hardest part about 3D printing is getting the squish on the bed done right, which we have seen already. So now I want to really kind of showcase the 3D printed parts. So here you can see this is the bumper. I just printed this. I printed it like this on the bed, so the bed is here. You can see the lines coming up. I just recently redid this, so it did used to have an open area here, here, and here. That wasn't very adequate, and so I actually updated it. You can see this squeezing it really hard, it doesn't break. It did break previously. I did print this at 100% infill, however, I think probably like 50 or 60% will be fine. You know, just something to note, maybe, you know, play around with it, or print it at 100. So this is a Ender S1. Out of the box, all that was done was the bed leveling. I changed it to a 0.6 millimeter nozzle and printed it. So that's the bumper, as you can see here. So I do have the Rock Pirate servo mount here, and then I have the spacer for it there. You should be able to pinch these together, but the bumper won't work, so I did develop the spacer for it. And then moving to the back, I do have the 77 millimeter spacer back here. I could cut some of this out and make it more light, if you will, but I don't know, there's really no reason for it. And then these are the tabs that the body mounts into. You can see that they are printed, much like how I just showed you in Prusa. You do put those on, there's 2 screws there. They go through the tab into the spacer, and then they screw in. And then in the front, you can see that the servo mount screws in here, and I can see a design flaw on the servo mount here already. I forgot to put this screw hole in there. I will have to do that, but the servo mount screws in much like that, and then these screws go through the spacer into the servo mount, and then where the winch and the servo mount, there are screws that hold the bumper on. I think that's really all that I wanted to showcase in this video. Again, if you have any questions, comments, concerns, etc., please comment them below, and I will address them as soon as I can. Otherwise, thanks for watching, and have a good day.